All right, so in 8.5, we talked about permutation and combinations in terms of probability. So permutations was when the order mattered, when we were arranging things in a certain order, when we're trying to figure out how many different ways people can be in an order. Those are all permutations, which was the factorial. Then we talked about permutations taken a certain number at a time. So how many times can the runners in a race place first, second, and third? How many times, if I put like 5 chairs at the front of this room, how many different ways can I fill them with a group of 20 people? Something like that. That would be permutations taken a certain number at a time. And that's the PRN. So permutations in general is going to be the number factorial. And then we had a permutation taken a number at a time. And that's your PNR, and that is n factorial over n minus r factorial. And then we had combinations, which was just how many different ways something can be pulled, okay, where order doesn't matter. So A, B, C would count the same as B, C, A in a combination. It's just a part of it. It doesn't matter what order it's in. And that's when you use your C and R, just like we used for our binomial coefficient, which would be n factorial over n minus r factorial times r factorial. So those were really the 3 equations or formulas that we used from this chapter. From this section. So number 1 says determine the number of ways in which a computer can randomly generate a pair of distinct integers from 1 to 15 whose sum is 20. What does distinct mean? No, so integers is the whole number part of that, right? But what does distinct mean? Yeah. Can't be the same. So what does that mean in terms of this numeric set?
10 and 10.
I can't use 10 and 10. Does that make sense? So there's 2 different ways that happens. Like if you think about it in the last couple of examples that we had done, it would have said a piece of paper, you pull out the piece of paper, you replace it or you don't replace it. That's one way to impact if a double number can be used. Another one is if it's randomly generated from a computer, you're assuming you're starting with a fresh set every time. But the fact that it says distinct means I can't use the same integer twice. So in which combinations of numbers would I get a sum of 20? 5 and 15 is one of them. 6 and 14. 7 and 13. 8 and 12. 9 and 11, and then it would be 10 and 10, but we said we can't count that, right? Because that would not be distinct. Now, is it different if the computer randomly generates 15 first and then 5 the second time? It is different. That's a different way to get the same sum. So if there are 5 this way, there are 5 the reverse way. 15, then 5, 14, then 6, 13, then 7, 12, then 8, 11, then 9. Which means there are 10 ways to generate distinct integers that sum to 20. Number 2 says telephone numbers in the U.S. have 10 digits. How many different combinations are possible within each area code? Note, a local phone number cannot begin with 0 or 1. So the first 3 numbers, there's technically 10 numbers in a phone number. But they're saying within an area code, which means the first 3 numbers are already set. If the first number cannot be a 0 or 1, how many choices do you have for that first number? 8. Then how many for each remaining number? 10. So that is 1, 2, 3, 4, 5, 6 zeros. Oops. Or 8 million combinations. Questions on that one? Okay, number 3 says how many different ways can 5 couples pose for a prom picture? Assume each couple stays together. Which means although there's 10 of them, we're really treating them as though there's 5. So is this permutation or combination? Permutation, right? The way in which they're arranged is changing. It would be different. If couple 1 goes first, couple 2 goes second, and then I switch those, that's a totally different picture with different poses. So this would be 5 factorial. Or 5 times 4 times 3 times 2 times 1. That's 20. That's 60. That's 120. Questions so far? Oh, I didn't add distinguishable onto that first slide. There's also distinguishable permutations, right? So if you have something with a repeated factor, then I would put n factorial in the top over each repeated term, however many times that repeated term appears, right? So what's the total amount of letters in weekend? 7. Okay, W only occurs once, so technically it would be 1 factorial, but you don't even need it because 1 factorial is 1. Then I go to E. How many times do you see E? 1, 2, 3 times, so that's 3 factorial. Then I go to K, it's only going to occur once. Then I go to N, it's only going to occur once. And then I go to D, it's only going to occur once. The ones really don't matter. You can put them there if it helps you, but you honestly don't need them because each of those is just going to be 1. So this is 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. That's 42, 21, 840. Questions on that one? Okay, and then number 5 says you can answer any 12 questions from a total of 14 questions on an exam. How many different ways can you select the questions? This is where it's so tricky, right? Because this actually says the same word ways as this is, okay? But these are 2 totally different questions. One is I'm taking it a certain number at a time, first of all. But 2 is that the order of which you answer these questions is not part of the problem, which means this is not a permutation, this is a combination. So it's just how many ways can you pull 12 questions from that 14, not in which order would you answer those 12. Does that make sense? So even though they both say how many ways, they mean 2 totally different things. Think about the poses. That's going to be the order. If you can rearrange something and it be different, that's when it's permutation. If you're just pulling a set of questions off a test and it's not talking about the order in which you answer them, this is combination. So this is a combination out of 14, so N is 14, and you're taking them 12 at a time, so your R is 12. This is C, 14, 12. So it's 14 factorial over 14 minus 12 factorial times 12 factorial. 14 over 2 factorial, 12 factorial, which is 14 times 13 times 12 factorial over 2 times 1 times 12 factorial. The 12s cancel out. 2 goes into 14 7 times, and that's 91. Questions? Questions on the homework that was due this morning? So I will say that there was one, I got like a question on the weekend about the phone number with the even and that kind of stuff. Is everybody okay on that? Yep. So it said, same question, area code, right? So it was within an area code, right? So the first 3 digits were set. And then it said, following example 4, and I posted example 4, but example 4 just said it can't start with a 0 or a 1. So we started with 8, right? And then it would have been 10, 10, just like our example at the beginning. But then one of the things said the last digit has to be an even number. So what are your even numbers between 0 and 9? 2, 4, 6, 8, 0. Yes? Those are even digits. How many of them are there? 5. So instead of this being 10, this is now 5. Same thing would have happened if it's odd. Okay? So, or if it said it had to begin, like, I don't know, if it said it had to begin with a 5, let's say. Now this one is only one option. It has to begin with a 5. So just think about how it would reduce your set if you did that. And then obviously you would multiply out what's left.
It starts off with the certain thing has 4 area codes, so you're just ignoring them?
So if it had 4 area codes, then there's 4 different ones on the front. Then there's 4 different. Because no matter what those 3 combinations are, you're saying that there's 4 options there. Any other, what was Daniel, was that your question or? Yeah, okay. Any other questions from the homework?
You just multiplied 4 times.
God bless you. Yes, if it said there was 4 area codes, then you're going to do 4 times whatever's there. If it said there was 3 area codes, 3, 2, 2. Because I think they had that changed in some of the questions. All right, so the quiz. All right, number 10 said a school locker has a lock dial on which there's 39 numbers from 0 to 38. Find the total number of lock combinations when the lock requires a 3-digit sequence of left, right, left, and the numbers can be repeated. So there's 3 different numbers I'm looking for, and each of them comes from 0 to 39, which means this is 39 times 39 times 39, which is 59,319. If it had said it couldn't be repeated, then it'd be 39, then 38, then 37, okay? But if you can have the same number repeat on a combination, then, and the left, right, it doesn't really matter. You're just looking at them as 3 separate ones. Any other questions from the homework? Danny. Is going to cover 8.4 and 8.5. There are no calculators. It's going to be quick. It's going to be 6 questions, but remember one of them is a binomial expansion, so it takes a little bit of time, okay? And I think you have a total of a half hour from the time you walk through that door to the time you leave, so you got to move fast. Half hour is going to be plenty of time, but you just want to make sure you're prepared and punctual. All right, so if you've got, if you go back to 8.4, 8.4 was our binomial theorem. And there were three different types of things in here. One was Pascal's triangle. Remember that starts at 1, then 1, 1, then 1, 2, 1, because you're adding the 2 numbers above it and you're pulling that down. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. I'm just going to stop when I get to the bottom of the page. 1, 7, 21, 35, 35, 21, 7, 1, 1, 8, 28, 56, 70, 56, 28, 8, 1. Okay. So technically, if I count them here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. So if I ask you to give me the first 5, you give me the first 5. If I ask you to give me the first 6, you give me the first 6. Okay? That's different than if I said go to the 7th row, because remember the first one is the 0 row. My advice is obviously know it because it's going to be a question. 2 is use it for expansion because it makes your life easier for expansion. And remember whatever power you're raising it to. So if I have something that's raised to the 7th power, then I'm looking for the row that has the second number that matches that exponent. So if I'm on the 7th power, I'm taking these coefficients.
So if it says to just go to the 7th row,
then literally list 7 rows. If you count from top to bottom, there's 7 rows. Correct. And remember that if this is 7, right? If n is 7, there's always one more term than that. So there'd be n terms, which would be 8 this time, and then, or not, n plus 1, sorry, n plus 1 terms. So there'd be 8, and if you count 1, 2, 3, 4, 5, 6, 7, 8, now you know you grab the right row. So I would use Pascal's for the expansion. I would probably not use it for the nth term, which we'll talk about in a second. Let me go.
So say you ask for the 3rd row, would you go to the row that says 1, 3, 3, 1?
Yes. So the 3rd row is technically 1, 3, 3, 1. Okay? But I will ask you to write the first number of rows, and you just need to give me that many. I don't need to confuse you. When you're saying the number of row, the first row is the 0 row. And then it would be the first row, then the 2nd row, then the 3rd row. But if I say give me 7 rows, I mean literally give me 7 rows, not like give me the 7th row. Don't go to the 8th row. I'm not going to try to throw you off.
you're including the 1.
You're including the 1, yeah. All right, so then after this came the the expansion, something like 4x minus 2y to the 4th power, let's say. And it would say expand that. So this is where you're going to, first of all, how many terms should my answer be? 5, one more, right? You're going to expand this out by taking the first term, raising it to the highest power, working its way down, second term to 0, working its way up. So this would be 4x to the 4th. And then I could put negative 2y to the 0, but honestly, you don't need it. Leave your space for your coefficient because you're going to come back and fill that in. Then it'd be 4x to the 3rd to negative 2y to the 1st, 4x to the 2nd, negative 2y to the 2nd, 4x to the 1st, negative 2y to the 3rd, and then 4x to the 0, which you don't need, but I'm just showing you that it would be there, and then negative 2y to the 4th. So that's the first step. Then I'm going to fill it in with the row is probably the easiest because I'm going to ask you for Pascal's first. So if you've already written out Pascal's, then I'm going to the row in which it starts with 1, 4, right? So that is 1, 4, 6, 6, 4. Oh, no. Sorry, I was right the first time. 1, 4, 6, 4, 1. That and top to bottom would actually be the 5th row if I'm counting from top to bottom, but it's the one that starts with 4. Okay, then I want to multiply them all out individually, right? So I'm going to go to the first one. I'm going to multiply all these out. So 4 times 4 times 4 times 4, so 64 times 4. I try to go easy on the numbers, but that is a possibility. That's 256. X to the 4th. There's nothing here because that would be a 1, and that times 1 is 256. X to the 4th. That's my first term. Then I go to the second group, and I would cube this first. So 4 times 4 times 4 is 64, x to the 3rd. And then this is negative 2y to the 1st. So 64 times negative 2 is negative 128. And then negative 128 times 4 is negative 512. X to the 3rd. Y to the 1st. And then I go to the next group. So this is 4 squared, which is 16x squared. Negative 2y squared, that's a positive 4y squared. Times 6. So 16 times 4 is 64. Times 6. 384, and it's positive. Then I go to the next group. This is just a positive 4x. Negative times a negative times a negative is a negative 8y to the 3rd. 4 times negative 8 is negative 32. Times 4 is negative 128x y to the 3rd. And then the last term, this would be 1. Negative 2 times negative 2 times negative 2 times negative 2. That's positive 16y to the 4th times 1. Positive 16y to the 4th. Yep. Mm-hmm. Questions on expanding. So that's the one that's probably going to take you the longest. Just be careful. Okay, watch your signs. Make sure you multiply by the coefficients. Mistakes here are like that people will add instead of multiplying. Forget the negative, silly stuff like that. Okay, and then the third thing in 8.4 was your actually just finding an nth term. So this is CNR, first term to the n minus r, second term to the r. So let's say from this one, I asked for the fourth term. I won't ask from the same binomial, I'll warn you now. But just for example purposes, let's just say I use this one. So if it's the fourth term, what is R? 3. It's always one less, okay? So my N is 4 and my R is 3. So I am doing C 4, 3. And then I get 4x to the 4 minus 3. And then I get negative 2y to the third. So this is 4 factorial over 4 minus 3, which is 1 factorial times 3 factorial, 4 times 3 factorial over 3 factorial. This is 4 times, this would be 4x to the first. And this would be negative 8y to the third. So this is 16 times 8, negative 128, x to the first, y to the third. Which matches what we got. Questions on that one? Okay, and then 8-5 is where we were. So 8-5 is your simple counting. So this is permutations. This is permutations, number at a time. This is distinct. And combinations. So this would be n factorial. This is PNR, which is n factorial over n minus r factorial. This is n factorial over n1 factorial, n2 factorial. And this is CNR. So for permutations, you're thinking things like how many ways can something be arranged, in which order can they finish, that kind of thing. And then permutations a certain number at a time. How can they finish in first, second, and third? How can they fill president, vice president, and secretary position, that kind of thing. If it had just said in which way can they be in top 3, now we're not talking about first, second, and third. That's when it switches to combination. If I said 15 candidates are running, 4 of them make it into office, how many combination, I actually wouldn't say combination, and how many ways can it happen that those 4 people would make it into an office? Now that's combination. Does that make sense? Because you're not saying, you're just saying 4 people make it into an office. I don't care which office they're going in. Or 4 people make it into president, vice president, and secretary. Now we're talking about permutation, a certain number at a time. Does that make sense? Yes? So you're in the Olympics. You just want to place. How many different, if there's a team of 50 people, how many ways can they place? That's combination. You want to see the different ways they can place first, second, and third. Now that's permutation because the person A can go to first place or person A can go to second place, and those are 2 different methods. If they're just placing overall, then it doesn't matter if they get first, second, or third. They're placing. That's when it's combination. And there's always going to be, like, permutations is always going to be more than combinations. Questions on expectations for the quiz? Okay, again, no calculator. So when you're doing the review, try not to use your calculator. Yes, that means some multiplication. You could do it. I have faith that you can multiply 2 numbers by 2 numbers, or 2 numbers by 1 number, or 3 numbers by 1 number. Just be really careful. Yep.
Would be